Okay, let's look at those concepts we learned before. Okay, the median, altitude, angle bisector, and perpendicular bisector. Let's look at this. Over here, AB and BC equal. Then who is the median of APC? Okay, Shirley, go ahead. Answer number 1.
If AB equals BC, then
AB and BC equal. So BP is a median.
BP,
yes.
yeah.
So BP is a median. So this is asking us the definition of median. You connect one vertices with the opposite side midpoint. This is called median. Okay, go. Do one more. Next. Read here and tell me what you want to choose.
If line PC is a perpendicular bisector of BD, then BC is equal to DC.
Okay. So if it's perpendicular BD, okay? Yes. Hold on. 1 second. One student didn't get in. Keep going. You guys first try to look at this. I have a student who had trouble logging. Next one, APD. APD is a right angle. If they tell you APD is a right angle, Mia, who and who are altitude? If APB is a right angle, for the right triangle, you can search not just that direction's altitude, you can search the other 2 directions' altitude.
A and D.
AP and PD. For the line segment, you needed to use 2 letters, okay? So AP and PD are the altitude of triangle APD. Do you understand this?
Yes.
This is a right angle, then AP and PD both are the altitude, okay? Next, look at this one, go. If PC is the median of triangle PBD, then who and who equal?
Then BC goes to CD.
Yes, that's right. They tell you that's a median, then C is the midpoint of BD, so BC equals CD. Next one.
If BC equals to CD and PC perpendicular
to BD.
Then perpendicular to bisector, then BC.
Yes, this equals this, and this is a 90 degrees. So who is a perpendicular bisector? That is a perpendicular bisector, right?
PC is bisector of BD.
Yes, that's right. PC is perpendicular bisector of BD. That's right. Next one, look at here.
If PC and AC are both altitudes of triangle PAC.
Yes.
Then angle C is the right
you don't,
angle.
when you only have one angle, you can see C. When this point you have different angles, you cannot just use one letter, you have to use three letters.
Angle PC.
PCA, okay? Because they are talking about the triangle PCA, right? Yes, PC and AC perpendicular, so this is right angle. Make sense now?
Yeah.
Next one. Number 7. Chloe. Let's try here. BX bisector ABC. So these two angles equal, okay? So you can have conclusion here is who, and the conclusion here is who.
And angles ABX
Yes.
is congruent to angle CBX.
Very good. Angle ABX is congruent to angle CBX. When you have these two angles equal, you can also know that DX is congruent to who?
DX is congruent to GX.
Yes. By what? How do you get these two congruent? First, you say BX bisect this. So you have these two angles congruent because?
Because BX bisects ABC.
Yeah, because definition of angle bisector. So you have these two equal. And then you have this equals itself because?
Of reflexive.
Yes. And then you have these two angles equal because?
Right angles are congruent.
Excellent. So you have these two triangles congruent because?
Because of angle side.
Yes, angle side. Very good. After you have this angle side, you can say these two congruent because?
Congruent parts of congruent triangles. Congruent parts of corresponding
triangles are
congruent.
Excellent. Wow. You made it perfect. Very good. One more here. If DX is perpendicular bisector of EB, means this is perpendicular to this line and these two equal. Yes. So ED is congruent to DB. And then XE is also congruent to
XB.
Because these two pieces equal. This is 90 degree. Right angles are congruent. This equals itself reflexive property. So these two are congruent. Then you do CP, CTC. You get these two congruent, right? Very nice. Next one, Ranisha. Ranisha, let's do this one together. You have XB congruent to XF right here. Then what's the conclusion?
XG is the perpendicular bisector of BF.
Yes. But let's know why. If you know this two, if you draw these two congruent, then you also know this is 90 degree. How can we give the conclusion that this guy is perpendicular bisector? Let's try to prove these two to be congruent first. How do we get these two triangles to be congruent? These two, you have, wait a moment. I tell you these two lines equal. And I tell you this equals it itself because of reflexive property. I haven't tell you these two equal yet. You cannot use SSS directly. What can you do? You can first use the Pythagorean theorem, right? You say, okay, this is a right triangle, so xf squared equals to xg squared plus gf squared. You say bx squared equals to xg squared plus bg squared. And then you can tell this equal and that equal, so you can prove that these two will be equal. After you prove this to be equal, then you will do SSS to get these two triangles to be congruent. After you get these two triangles to be congruent, you can see these two congruent because Chloe showed you just now. What's that called?
Side angle side.
Eh? You get these two triangles to be congruent because of side.
Oh, yeah.
After you prove the two triangles to be congruent, you can see these two angles to be congruent because these two lines to be congruent because
Of
do you know each letter represent what? Corresponding. Say it with me. Corresponding parts of congruent triangles are congruent. You prove the two triangles to be congruent first. Then you can say, oh, these corresponding parts of these two congruent triangles are congruent. Okay? So you prove this to be congruent so that, and also you prove these two corresponding angles are congruent. Yeah, this is 90 degrees, they are perpendicular. You prove this at the midpoint. You prove this is perpendicular. These two conditions satisfied at the same time. You will see this is the perpendicular bisector of this line. You cannot say this is the perpendicular bisector of that line. No. You see XG is a perpendicular of BF. And also, tell me, this angle congruent to who?
X AB.
XBF, XFB, correct?
Yeah.
That makes sense. Okay. Next. XD. If XD congruent to XG, what's your conclusion? If you give these two lines congruent, what can you say? You still want to prove these two to be congruent.
XB is the bisector of DBG.
Yes. XB is the angle bisector of angle DBG. But you don't get this in one step. Same thing. You will say this equals a self-reflexive property. This angle equals this angle, 90 degrees, right? And these two also equal. And then you can do the per-second theorem to get that to equal. Then you can say these two congruent by SSS. Then you can say these two to be congruent. Then you can say these two angle equal. But look at here. For triangle congruency, list the four theorem names. Go ahead. What are the four theorems we learned to do triangle congruent?
Side angle side. Side. Angle side angle.
Very good.
And side angle side, I think.
That angle side is here. The next one is
angle side.
Yes, you got it. This is for any shape of triangle. Doesn't matter it is right triangle or not. We also learned the full theorem for the right triangle to be congruent. Do you remember those theorems like HL? Kind of remember? If you want to prove, Elizabeth, do you remember the full theorem to prove two right triangles to be congruent?
Leg.
What are they?
Leg.
You can have leg. What do you mean leg? The right angle two side is called leg. The right angle opposite side is called hypotenuse. Hypotenuse is the longest line. Today we learn this, and from next class, we will start the trigonometry. We will spend 3 weeks for trigonometry. Trigonometry stuff are all dealing with special right triangles. So we want to know the two side of the right angle is called a leg. This two doesn't require to be congruent, okay? If it's congruent, you say this as a isosceles right triangle. They doesn't have to be equal, okay? They can be different. But we call if two triangles. Say if two right triangles, you have two legs correspondingly equal, you will say these two triangles to be congruent by leg. What else, Elizabeth?
Hypotenuse leg.
Can you speak louder, please?
Oh, hypotenuse leg.
Yes. HL. Very good. Next one.
Angle.
When no matter how you use the theorem, you need to prove two triangles to be congruent. You need at least one of the side. See? Side. Yes, you need at least know one side congruent. Otherwise, you won't be able to prove two triangles to be congruent. If I draw this, if you see side, if you see angle, see, I can easily make a different one. I can make this, see, look at here. I make this two angle congruent. I make this two angle congruent. Can I say this two to be congruent? No. You don't know the side information. You won't be able to prove two triangles to be congruent. So what are they?
Hypotenuse angle.
Yes, you got it. What's the other one?
Leg angle.
Yes, leg angle. Now let's refresh our memory. What's the reason we can change this three condition down to just two condition to prove triangle to be congruent? Because why? What do you think, Elizabeth? What's the reason this need three conditions? Why here for right triangle only need two conditions?
Because it's a right triangle.
Yes, because for two right triangle, you already know one of the right angle information. So for example here, these two, if you know that part, watch out here. If you know that two parts congruent, right? If you know two parts congruent, and you also know this part's congruent, okay? What's the reason we just need to know this one, two condition to know this to be congruent? Because you first will be a right triangle. So Pythagorean theorem will automatically apply. If this two corresponding equal, that two corresponding equal, you do the Pythagorean theorem, you get this two congruent. Okay? You get this two congruent. Then you can have SSS. So that's why HL is working. Same thing for LL. For LL, it's even more simple. You know these two lines congruent, you know these two lines congruent, and they have the same angle. Right angles are congruent. So this one is like SAS. The right angle is just between these two legs. This is corresponding to that. No, this is corresponding. Let's move on. This one is corresponding to that. This one is corresponding to that. Next one, HA. You know the hypotenuse congruent. And then you know one of the angles to be congruent. You know the hypotenuse congruent, you know one of the angle to be congruent. Then you will have 90-degree angle also congruent. So this is angle, side, angle, side. So this is corresponding to angle, side. This is corresponding to angle side. Now last one. This is not Los Angeles. This is called a leg angle. You have the first, these two pairs are congruent. And you have one of the angle congruent. One of the angle congruent. By default, this is 90 degree. So you have angle. See, you can know this side leg congruent also. If you know this side, you know this angle, then you call this angle side angle. But if you know this angle congruent, and if you know this two leg congruent, if you know this angle congruent, then you call this angle side. So this one could corresponding to angle side, or could corresponding to angle side angle. So for right triangle, you can simplify your proof by using this full new theorem, which is maybe simple to be applied. Next one. Over here. Emma. X is on the bisector of SKN. X is on the bisector of SKN. Then X is equal distance from who and who?
Wait, can you repeat that?
It's right here. You can read and answer.
Okay. K and N?
What do you mean K and N? To K to N. You mean these two equal? No. The definition, see here. I needed to introduce something a little bit more advanced. In XY coordinates, okay, we finished algebra 1. And after our geometry, we will do algebra 2. That's going to be a way more complicated, difficult course. In algebra 2, we will combine the knowledge you learned in algebra 1 and geometry. We call that thing called analytical geometry. In the XY coordinates, you can have 2 points. You can connect them. That's going to be the distance. You connect the 2 points, then you can do the distance between these 2 points. But when you call a point, when you have a new point, for example, I assign a point over here. If I want to say the point distance, I will draw this thing perpendicular to here. From a point to a line. You want to find the distance from a point to a line. You have to, number one, you have to draw the line. You have to draw a line perpendicular to it. So you have to draw this line, passing this point 90 degrees to the line. You draw this perpendicular, then you say the crossing point to this point location, this distance is the distance from this point to this line. So this question is asking you, X is equidistant. Equidistant. This is a compound word. Okay, compound word. First part is equal. Second part is distant. So they ask you, X is equidistant from what? X is equidistant from SK and NK.
NK.
NK and SK. Not comparing K and N. Not comparing K and S. It's equal distance to this line, to that line. They are asking you, hey, if I tell you these two equal, then you should be able to draw this perpendicular to that, draw this perpendicular to that, and these two are identical. It's equal, okay? So this is equal distance from SK and NK. Equal distance from SK and NK. Next one, do the similar thing, Emma. X is on the bisector of SNK. So X is equidistant to what? This is equal, okay? So answer here using the same method. Go.
It would be X is equidistant from SN and NK.
You got it. That's right. That's the thing I'm looking for. Makes sense now?
Mm-hmm.
Now, you can see this direction. You can see the other direction. Do the converse. Look at here. If X is equidistant from SK and SN, if this equidistant, then this X is on what? If I tell you this two congruent, then X is on what? Your answer is right here.
Oh, lies on the bisector of SKN?
And no, X is equidistant from SK and SN. You are talking about these two lines. Pay attention to here. You are talking about, they give you these two equidistance. So X is what?
X is the bisector of angle KSN.
Yes, thank you. You got it. I'm happy for you. That makes sense now.
Mm-hmm.
You see the way? They tell you this is the angle bisector, then these two equidistance. They tell you this is angle bisector, then this is equidistance. Now you can prove this two, because here equal and here equal. So you can say this is transitive property, this two equal. You get this two equal, then you must know that this is on the angle bisector of that angle, okay? Next one. Number 14. Elizabeth, let's try 14, please. Go ahead.
If O is on the perpendicular bisector of LA, then O is equidistant from L and A?
Yes. Very good. When you call equidistance, you could mean from the point to the line, then you draw the perpendicular. Sometimes equidistant could be from point to point. So this O is on the perpendicular bisector of that. So O is equidistant from point L and point A. Go ahead, also tell me, or you can make this conclusion saying these two equal. Why?
Because definition of perpendicular bisector L, what do you name that point? Okay.
Yeah, so I'm going to write a name. So I'm going to call this B, okay? Go.
LB is congruent to BA.
Yes. Definition of angle bisector, okay? Yeah, go. Keep going. Next.
And then definition of perpendicular BA, OBA, BL are right angles.
Yes.
Right angles are congruent.
Good, very good.
And then OB is equal to OB because of reflexive property.
Yes, very good.
So OL is congruent to.
Hold on. You have the triangle congruent first.
Right. OLB is congruent to OAB.
Yes.
Because side equals side.
Yes.
And then OA is equal to OL because of CBCTC.
Yes, very nice. You got it. Nice. Go. Number 15.
If O is on the perpendicular bisector of AF, then O is equidistant from A and F.
Yes. Next. Go ahead.
O is equidistant from L and F, then O lies on the perpendicular bisector of LF.
Yes. Excellent. O lies on perpendicular bisector of LF. Okay? Yeah. Very nice job. You get every part by yourself perfectly. Next one. Let's look at here. They give you what? They give you this thing. They give you this degree, this angle. And they said AD is altitude. Mia, go ahead. Based on the given condition, we want to find out the BC. Go. They give you this angle. They told you this is altitude. So you make this equal to how much?
We may.
This is altitude. Altitude means what?
90 degrees.
Yes. So solve that equation.
4x plus 10 equals 90. So 4x equals 80, x
Yes.
equals 20.
Good. Then we can solve BD will be?
BD will be 40.
DC will be?
60, so 56.
Thank you. Now give you a challenge question. We learned this thing. You know this part, you know that part, and I want you to calculate AD. How do we calculate AD?
Listen, you.
Do you remember the formula?
It was BD plus DC. No, it's like.
All the other students, do you remember the formulas that we learned? If yes, you can raise your hand. Who remembers this formula? Actually, my bad. I didn't say this is 90 degree, okay? Yeah, but now if I give you additional information, if I give you this is 90 degree, if I tell you this is 90, this is 90, so do you know how to solve AD? Search your notes. We learned this the second class. We learned this second class. Today is the 5th class of the Part B. We learned this in the second class. So it's 3 weeks ago. Search your notes. I don't want to directly give you the answer. I want you guys to search your notes to find out, so that next time you don't have the same mistake. And believe it or not, during the summertime, I go through this for my students who prepare for SAT. And after they take the SAT, they all told me, teacher, I'm so happy you told me this, because that question, because you told us the trick, the fast way, and we all get it correct.
Is AD squared?
Yes.
Equals to 2x, no, equals to 40 times 56.
Thank you. Right?
Yes.
Now
then
push you even further. Yeah, solving that shouldn't be a trouble. How do you calculate AB?
AB
AB square is who?
AB square.
Yeah, check your notes. Check your notes 3 weeks ago.
3 weeks ago.
Yes. AB square is BD times BC. See, the light is going in this direction, and you can treat this guy's shadow to be here. That guy's square equals this shadow times the whole thing, okay? So BD is 40, and BC will be 96, right?
Yes.
And then go. Same thing for AC square. How do you get AC square?
AC square was what is it? It was
that guy times that guy, right? Same pattern.
DC times BC.
Thank you. Which is 56 times 96. Okay? Make sense?
Yes.
So if this angle is right angle, then you can further solve this. Okay? I want you guys to pay attention to the things that you learned before. Okay? Next one. Do you still remember the angle bisect theorem? I remember I asked a student to do the proof. I asked 4 students to prove the angle bisector theorem with me before. Without checking your notes, let me ask. Shirley, if BD is angle bisector saying this guy equals this guy, what is the equation you can have from this angle bisector information? Who divided by who equals to who divided by who?
AB over BC is AD over DC.
Yes. Very good. AB over BC equals to AD over DC. If you want to do this way, that's also okay. AB over AD equals BC over CD. This is called angle bisector theorem if you were given these two angle equal. Okay? Now, those things are not counted as tough questions. All of you have printed out the worksheet, right? Okay. Yes. Now, go ahead. Draw this A, B, and C on your graph. But the B, X is 12, so you have to extend the largest X value is 10, so you have to go out by another 2. Draw your 3 points on the graph. Finish drawing this and then search. Search for the coordinates of K. CK is a median. CK is a median. If inside the triangle ABC, if they say CK is a median, then K is a midpoint of AB. CK is a median, so K is a midpoint of AB. So you can solve your K by doing the midpoint formula, okay? 1/2, 2 plus 12, that's your X value. 1/2, 5 minus 1, that's your Y value. So you can have this midpoint. Write down and calculate. And then go ahead. Do this. What is the slope of the perpendicular bisector of AB? You want to find this slope and you want to find that slope. Go ahead, do your number 21, also number 22, and send me your work. Let me grab some water. If you finish, send me your work, please. 21 and 22. Who finished? Nobody sent me work yet. Ranisha, you finished? You want to get the perpendicular bisector AB slope. Then you calculate the AB slope. AB slope and the perpendicular bisect slope will be negative reciprocal, right? Then you can get this one. And same thing, slope of CL perpendicular to AB. So these two slopes actually is the same because you calculate your AB slope, then the perpendicular line here has negative slope reciprocal of AB. Okay, so these two. Chloe, you finished? Who finished? Send me your work. I didn't receive any people's work yet. Oh, I received Chloe's. Thank you. Wait a moment, Chloe. You calculate the slope of CK. They are not asking you for slope of CK, Chloe. Oh, here. Yeah, you're solving 20. I'm asking you here. 21. You have it in the next picture. You calculate slope AB. Slope AB just by the y minus y. 5 minus negative 1 is 6. 2 minus 12 is negative 10. So you have that. And then you do negative reciprocal, which is 5 over 3. And for the C, slope of CL, this slope should also be the same as that because this is 90 degree, this is 90 degree. So these two lines actually is parallel. So they have the same slope. Okay. Next one. Let's do this. You have point N. N is on BC. So 20 to 23 are all using the same picture. N is on BC. N is on BC. N is on BC. And N has the coordinates. This is N's coordinates. And they ask you the NA is this altitude of ABC. So you want to calculate your BC slope. You want to calculate your AN slope. And you check this slope product if they are equals to -1. Vanisha, let's do this one together. Let's do the NA slope. Go. Point A is this. We drop down here. Point N is this. Let's do the slope calculation.
Wait, 1 sec. I sent you my other previous work.
Oh, okay.
Okay. 23?
What do you mean 23? You do this minus this, right?
Oh, okay.
You do this line slope.
So, yeah. So, 21 minus 5 is
21 over 5. Minus 5.
minus 5
Over?
over 8 over 5 minus 2.
Yes.
So
This
that
become
would be 4.
5 change to the denominator of 5 will be who?
25 minus 21.
Thank you. 25 over 5. Then the bottom one, 2, is what?
So then that would be 8 minus 10.
Yes. Now, tell me.
So that would be 2.
So look, this is the 5, and this is 5. Can you ignore the 5 immediately or simplify? Yes?
Yes.
Good. Very good. 21 minus 25 is?
-4.
8 minus 10?
-2.
This become?
2.
2. So how many students here? I ask you guys, if you have A over C, you will have A over 5 over B over 5. When you have these complicated fractions, when you have these two are identical, do you know that you can cancel this immediately? How many of you will cancel this immediately? If you, yes, raise your hand. If you don't know this method, I want you to be able to cancel it, okay? A over C divided by B over C is same as A over C divided by B over C. So you will times this reciprocal. So you do A over C times C over B. So immediately this is A over B. I don't bother to carry on the C over again. But if you have A over C over B, some people say cancel the C. No, you cannot cancel this C. This C are not on the same position. This C on the same position you can cancel. This C, no, you cannot do that, okay? Don't confuse yourself. You check this slope is 2. Then you will check the BC slope, yeah? So you will do the BC slope by doing 8 minus -1. Let's calculate the BC slope. Let's go ahead. Do the BC slope, please. Go ahead. Vanisha.
So BC slope would be 5.
Hold on. Not using A. You do BC. Yes.
Oh,
BC.
BC.
Go.
So then
8 minus
8.
-1.
So 8 plus 1 divided by 6.
-6.
Yeah, -6 minus 12. So that would be 9/18.
9 over -18.
Yeah, so that would
Which is
be -1/2.
-1/2. Now, do we see that these two are perpendicular? Yes. Because they're reciprocal. They are negative. Their slope product is -1. So it is perpendicular, right? Yes. 2 times -1/2. This is -1. Remember I showed you guys this in before? If you have, for example, if you have y equals to mx, you add a slider so that you can change your slope. And then you can make your y equals to -1/m. Given a slope of m, you get the negative slope, which is -1/m, and then you times by x. No matter what your slope is, these two lines, you see, it is always perpendicular to each other. No matter how much you change the line slope, it is always 90 degrees all the time if their product is -1. Okay? Yeah, that's what's going on. I know but this week is short, right? You guys take just 3 days of class, but looks like everybody looks so tired, right? Next one. Let's look at this. We learned the rotation formula. Let me ask if students still remember this rotation rule clearly. Let me call you guys. We did this. Elizabeth, what's the rule for rotate a 180 degree?
It becomes -x, -y.
Your x and y both flipped. X to be -x, y to be -y. So that's exactly 180. For 180, doesn't matter you are clockwise, counterclockwise, or clockwise, right? It's the same. You rotate this direction 180, you rotate the other direction 180. It is the same point. Next, x, y go to 270 degree rotation becomes to what?
Becomes, wait, this is counterclockwise, right?
This is counterclockwise. By default, it's positive counterclockwise.
Okay. It becomes y -x.
That's perfect. This is y comma -x. When you rotate, here is a quick way to help you write down this rule very quickly. No matter what, if you have all the numbers of 90 degree, for example, you rotate 90 degree to 70 degree, or you put 450 degree, yeah, times 3, times 1, times 3, times 5, times 7. If you rotate those odd numbers times 90 degree, you want to do XY switch to be YX. Okay? Next, based on the direction, if you go to 270, your quadrant 1, suppose originally your position is X1, X, Y in quadrant 1. You rotate a 270, you will come to quadrant 4. If you come to quadrant 4, then the position, this quadrant 4, you have a positive x, negative y. So you want to flip this to be negative. Now, that's why Elizabeth has this correct answer. If you rotate by 90 degrees, counterclockwise positive, then the rule will be you first flip xy, make y to x. If you go from quadrant 1, you rotate 90 degrees, you will come to quadrant 2. Quadrant 2, x position is negative, y is positive. So you put negative y, comma, x. If you are asked, for example, 90 times 5, say 450 degrees. If I were you, I don't bother to make myself dizzy, rotate another. I will minus this by 360. Whole circle is 360. So if I do 450 minus 360, this is the same as 90 degrees. Okay? When you have a number greater than 360, you want to definitely to minus 360. If one time is not enough, you minus again to change that to be 90 degree or 270 degree to be easy to apply these two rules we learned. Any questions so far? Is the question I teach here harder or easier or about the same level of your school? Any comments here? Mia, the thing I teach here is the same level?
About the same.
Okay. If your school have harder topic, let me know, please.
Okay.
Shirley, how about you? My stuff is harder or same level of your school?
About the same level.
Okay.
A bit harder.
Next, we learned the reflection. Remember, last class, I teach you guys, if you reflect it over the y equals x, reflection over y equals x, you just flip them. Yeah. So if this is 4, 2, you don't need to draw. Immediately you flip by this should be 2, 4. But not always they give you such a simple line like y equals x. So here is my requirement. My question is, I have 3, 2. This point is 3, 2. And this is the line. This line is y equals to 3 over 2. Rise over the run by 3, run by 2. So slope is 3 over 2. And you have y-intercept at 3, 0, 3. This is the line of symmetry. You want to reflect this point through that line. This is your mirror. You want to look for your image position. You will draw this perpendicular line first. And then you will connect them and extend equal distance. So that's going to be your image point. I teach this thing last class. Show me that you still remember how to do it. Quick summary. Step 1. The purple line slope is negative that. These two lines perpendicular, so of course, you should do the negative 2 over 3 as this line point, this line slope. You pass this point, you have negative 2 over 3 as a slope. You have this purple line equation. You solve this purple line equation with this green line equation, you have the crossing point. The crossing point is a midpoint of these 2 points. You use the midpoint formula to find that. Go, do by yourself. On Thursday class, I have more than half the students get this question correct. Show me this class, you can also do it. If you need help, you can unmute yourself. I can do with you together. While you guys are doing this question, I share a small story on myself. Okay, yeah. Like most of your parents, I'm the first generation immigrant to US. So when I first want to find my first job, I don't have the green card. I'm not a US citizen. So to be able to be hired, it is really difficult. So finally, I found several companies who can sponsor my H-1 visa. So one of the company is the best one compared to the others. So I really want to go to that company at that time. I passed the first two turns of those technical interview. Okay, yeah, and then the last turn is the VP. He interviewed me. So he checked my education background and he asked a couple questions. I did pretty well. And then he figured out a tough question to ask me. It's a tough question. And during the time, I was very nervous. And he kept watching his wall and knocking the table, make the noise, make me very nervous, very stressful. I was sweating. I was like horrible nervous. And I think I'm not able to solve that question. I cannot calm down easily. I feel so desperate. And then I look outside the window. I see the beautiful company campus. I was thinking, even if I don't get this one, it is not the end of the world. I can relax and I should be able to handle that question. And then I calmed down, I relaxed, and then I get the answer. I gave the perfect solution with those coding. And that VP smiled. And he said, I know you can solve this question, but I just want to see How can you solve the tough question during the stressful situation? That's the thing I'm looking for. So during my class, I give you some tough question within a limited amount of time. I want you guys also being able to do every step perfect in front of me with small amount of time and present me your perfect solution with perfect steps. Go ahead, send me your work. You might heard from some parents or some other people. They say, oh, when you go to high school, girls will not be as good as boys, especially when you start to learn classes like AP Physics, AP Physics 1, or AP Physics C, or Calculus AB, Calculus BC, AP Pre-Calculus. That's the time girls will fall behind. That's not true. Girls can also do STEM very good. Your girls here all can do it. But you need to push your limit. You feel like, I'm not able to do it. I'm not so that smart. I'm not able to handle those tough questions. You step out of your comfort zone. You push yourself a little bit harder. You are able to do it. I on purpose designed this question, which makes this question each part number not friendly. If you send me your work, I'll check. If you did correct, I will announce your name. If I didn't announce your name, that means there is careless mistake. Oh, Chloe. Look at the beginning, the first step. You have y minus 2 equals to negative 3 over 2 times x minus 3. Yes? Chloe, did you do distribution? Negative 2 over 3 times negative 3. Fix that point and redo it. Okay? Yes? Other people, send me your work. If you do dancing, I know some dancing school has really tough dance teacher, right? Yes. If you make in the team, if you make one small mistake, oh my gosh, you have big trouble. Your mom also have big trouble. So you want to pay attention from the very beginning. If you miss the distributions in the first step, you have to start over everything. Who else finished? Mia, are you doing okay? Elizabeth, almost finished?
Yeah.
Okay. You might wonder, why is this teacher always torturing us by giving some big, ugly, disgusting numbers? If you can handle my stress here within a very short time and present me a perfect work, you will be so confident for your school's quiz test, major test, the final, progressive test, and also those standard tests. Okay? I trained so many kids get perfect score, yeah, either for their PSAT, SAT, or ACT, or their school's test, you know. I trained girls to be perfect on math and science. Surely, your X is perfect. The Y is so close. X value is perfect. Small tiny mistake for the Y value. Last several step double check. Elizabeth, you get a perfect X value and perfect Y value. Yes, very nice. This class definitely can compete with Thursday's class. Wait a moment. Mia, how come you have a positive? You have 12 over 13 minus 39 over 13. It is negative. Yes? Mia, did you see? So, girls, during the test or quiz, you draw a negative, small negative on your left hand. You always pay attention to that thing, okay? Yeah, I told you many sad stories of students miss a negative and get 20 points off or 30 points off in their test. You don't want the same sad story happens to you. Okay? Other student, let me see your work. Chloe, what's your final solution? You have many steps. What's your final solution? Box your final answer, X and Y value. So all the students, even you haven't finished, still send me your work. I'm able to quickly find out where your first mistake come from. Okay? May I change your small tiny mistake? Thank you, Shirley. You got it. Okay, that's right. So you guys see, when the number becomes ugly, disgusting, it is hard, it is tough to get the perfect answer in a very short time. Other people, send me your work. Ranisha, send me what you have right now.
I sent.
Oh, really? I keep refreshing. I haven't received. I don't know why. Thank you, Mia, for fixing. Emma, send me your work.
It's sending right now.
But yeah, you get the correct answer. Yes, you get the perfect correct answer. That's right. Good job, Emma. Is my Gmail box full? I don't think so. Why I don't receive Lanisha's work? Very weird. All right, let's look at this question. All the other question, I show all the step-by-step work. Okay, so you guys can do it. Use my notes to finish the homework. Let me talk about this one. You can do the point reflected. You can do a point reflected over line to find the image. You can also do the line equation. You can do the line equation reflected over different lines to find the new lines equation. So for example, this one, y is equals to negative 1/3 x plus 4. Negative 1/3 x plus 4, you have the y-intercept at 0, 4. You have the slope as negative 1/3. So you have this line equation. And they ask you this one reflected over x equals -2. I like to draw in the graph to help me solve quickly. Anisha, go ahead, unmute yourself. Let's talk about how do we solve this. This y equals negative 1/3 x plus 4 is on the right, okay? And they ask you this line reflected over x equals -2. X equals -2 is what kind of line? This is what kind of line?
A vertical.
A vertical line. They want you to reflect this over the vertical line. So you reflect it come to the left. Yes? This line reflected come to this. What do you think? This line slope is how much?
1/3.
Negative 1/3, right?
Oh yeah.
After the reflection, you think the new line slope will be?
1/3.
Yes. When you reflect it over a vertical line, your new one and the old one slope should be negative to each other. So this slope will be 1/3. And look at here. The new one and old one crossing on this line of symmetry, right? So basically, you want to solve this point position. How do you calculate this point position? What do you do?
You know that the neg
Yes? Go. Say it.
you know that the
X
the
value
point is on the line for the x.
Yes. So you plug in, right? You plug in. These two lines cross, so x is -2. So the y position will be -1/3 times -2, then plus 4, right? which is 2 over 3 plus 4.
3 plus 4.
Yes, okay. So you have 2 over 3 plus 4, which is 14 over 3. So that is your point location, right? You pass -2, 14 over 3. You have a positive slope of 1/3. You can do the point slope format to calculate this equation. Yes? That's how we do this one, okay? This is reflection over a vertical line. You solve the crossing point, you use this point, and use this slope, which is negative to that one. Do the point slope, you have the new line equation. Part B, Shirley. Read this, what they want us to do. Shirley?
You translate it down to units.
Yes, so you translate down. This is a vertical shift. So every point on this line will shift down by 2. Your old y-intercept is x equals 0, y is 4, right here, yes? Your shift down becomes
0, 2.
0, 2. And you can have another point. You can see if you plug in x equals 3. If x equals 3, y will be? -1 plus 4, right? Which is 3. So this old line must pass 3, 3. Now you shift down by 2, so 3, 3, 2, 3, 1, right? Yes. Come to 3, 1. And you have 0, 2, you have 3, 1, then you can do this line equation, correct? You can do
Yes.
And actually, you can use this 2 points shift down based on this 2 new point location. You can do the slope calculation. You can do the point slope format. You can have the new equation. Or you don't worry to calculate that. You just know that after shift, your line, new line, and old line slope should be exactly the same, right? You shift down, it is parallel, right? Yes. Because why? Because look, these 2 vertical lines are parallel. And you shift by 2, so this equal. We learned in our geometry part A, when 2 lines here, same length means equal and parallel, then this will be a parallelogram. If this is parallelogram, then these 2 lines slope equal. So the fastest way is by using the slope y-intercept format, because you pass 0, 2, you have the same slope. So actually, I can write down this in one step. Same slope, shift down the b value by 2. So that's it. See, you don't need to use these 2 points to recalculate. You copy the slope, you have the new y-intercept shift down by 2. Shift down by 2. Number C, Mia, rotation. We review the rotation formula, from Elizabeth. This point, you rotate it by 180 becomes what? 0, 4 rotated by 180 becomes?
0, -4.
Thank you, 0, -4. You have the old line like here, you have the new line like here. What do you think their slope relationship, this new and old slope should be?
They're going to be the same slope.
Yes. This point rotate 180 come to here. If you know this guy's x-intercept is 12, 0. It rotated by 180, it comes to -12, 0. And you connect this and this must be parallel. So you can get this one very fast by, go. What's the line equation? Y equals? Go.
Y equals -1 third x minus 4.
You got it. Very nice. We don't bother to use a slow way. You can do that. You say, oh, this one's x-intercept is 12, 0. So rotate 180, negative 12, 0. And then do the slope calculation, and then do the point slope format. But you should know, this thing is symmetric over here. This thing is symmetric over here. So actually, these two triangles are what? These two triangles are what?
Similar?
Congruent.
Congruent.
Do you see? This
Yes.
equals to here. This equals to here. And they are vertical angles, so these two triangles to be
Congruent.
congruent. When they are congruent, you say this angle congruent to this angle, yes?
Yes.
Because what?
CPC/TC.
Corresponding parts, corresponding angles in the two congruent triangles are congruent. So you have these two angles congruent. Then you have these two lines parallel because? What's
Because
this
they have
two
the
angle?
same slope.
This
They
angle
have
is this angle is called what angle?
alternate anterior angle.
Yes. Knowing these two angles congruent, saying the line parallel, you say what? Remember?
Converse.
Yes. You said alternate interior angle converse, then you have these two lines parallel. These two lines parallel, that slope and that slope is the same. The thing we're doing here is called analytical geometry.
Oh, it's too late for this.
Okay? It's analytical geometry. But everything you have learned in geometry will still apply here. Okay? Yeah, it's not too late. We start a little bit late, so I give you students extra 2 minutes. That's for today's class. Make sure do the 3 worksheet, all the homework, try your best. Starting from next week, we will do the trigonometry. Many students really struggling with trigonometries. So make sure do your hard work, okay? Yeah, trigonometry. If you learn here with trigonometry with me, you have foundation enough for you to handle the SAT part. You don't need to go to those test master to relearn those things. Our next 3 class, you do hard work with me. For any trigonometry question in your SAT, you will be perfect. Thank you, everyone. See you next week.